but you can also specify a label. So in this case, I'm specifying a label, which is kind of handy because I don't have to remember all the different line numbers. So I set a breakpoint at check here. I can run my program at full speed, just using R, and it gets to that point, it stops. Okay, it didn't crash. So at this point, I can go IR EAX, and EAX now has CCCD, as its content. Now, when it shows CCCD, it really means 0000 CCCD because the leading zeros on the left-hand side are not printed. So that means the most significant 16-bit of EAX, they're all zeros in this case, which doesn't meet the requirement of the homework assignment. So, I have to go back and try to figure out what to do with the homework assignment to make it work like this. So are there any questions about the commands that you have to use and how to get the whole process to work? No questions? Okay. Some of you may encounter this particular error. So I will go ahead and try to make this crash. Okay. So if you put in a 0 here, it will definitely crash, and I'll explain that when we talk about the direct operand. So we have to. Okay. Here's another shortcut. Exclamation point AS is going to repeat the last command that starts with the letters A and S. Okay, so it's very handy. Okay, and the same thing with LD. So now I can just repeat all the commands as last time. Put a breakpoint at check here. Run the program, and this time it has a segmentation fault. In fact, it doesn't just tell you that the program crashed. It tells you it crashed on line 20. Okay. While it was trying to execute the instruction on line 20, it caused a segmentation fault. A segmentation fault happens when your program is trying to do something that it is not allowed to. In other words, in most cases, is when it is trying to access a memory location that is not accessible from your program. Are we doing okay so far with these methods? Okay. So let's go ahead now. I'm just going to get out of this program and talk about memory operands, because that's the focus of today's lecture. Is how do we deal with those memory operands? And all of that stuff. We kind of started talking about that last time. With addressing modes and memory allocation. So we'll just go ahead and continue with that topic today. Pretty slow. There we go. All right. So last time we talked about the immediate operand. An immediate operand starts with a 0. It starts with a $sign. Whatever is after the $sign, the entire expression after the $sign has to evaluate to a specific value. Has to evaluate to an integer. That integer in return, or in this case, it has to be a 32-bit integer because it's a long. That 32-bit integer becomes a part of the instruction. In this case, it's a push instruction. An operand like this, the immediate operand, can only serve as the source of an instruction. It can never serve as the destination of an instruction because you cannot change an immediate operand. You can only use it as a source. Are we still doing okay so far? We talked about this instruction last time. The next slide talks about the registers, and we kind of talked about the dissecting of register EAX. So EAX can be dissected into AX. So AX refers to bit 0 to bit 15 of register EAX. Bit 0 to 7 is also known as AL. Bit 8 to bit 15 is also known as AH. So that's what we talked about last time. And there was a sample program that I wrote last time, to illustrate all of that stuff. Do you guys still remember on Tuesday? We kind of talked about that. Okay. All right. So there are some additional registers. ESI and EDI are source and destination index registers. I don't use those registers in this class. I don't really have a need to use those. ESP is special. It is the stack pointer. EBP is also special. It is called the frame pointer, which is also known as the base pointer, and therefore EBP for base pointer. So those two are very useful, and later on we'll talk about how those two registers are going to be very useful. Are there any questions at this point? No questions? Okay. If there are no questions, I'll just kind of go through this particular example here. This is a move instruction, which means we're copying the bit pattern from the source to the destination. In this case, the source is %EAX, which is register EAX, and the destination is EBX, which is the register EBX. The % symbol is mandatory. You cannot miss the % symbol. Now, if you do miss the % symbol, it will give you an error message at the wrong time, and it will not tell you that it is missing a % symbol. It will tell you something that's completely different and seem to be irrelevant to the actual problem itself. Okay? I'm not going to show you. You have to do it yourself. Okay? So look at this as an exercise that you should do, because you will only benefit from this little simple exercise. It will take you about 5 minutes or so once you know the command. So just go ahead and write a program with this instruction, but intentionally miss the % symbol. Okay? Then you go through the assembler, and you try to go through the linker, and then see which one complains about it and what message you're getting out of the whole thing. Okay? The reason why I think it's a very useful exercise is from time to time we'll make that mistake. Okay? Forgetting a % symbol. Okay? It just happens. Okay? It will happen, and it will happen again and again. So the question is, when it does happen, do you know what the problem is, and do you know how to fix it? So now that we have a little bit of time, at the beginning of the semester, I think it is useful to kind of go through all of that stuff, experiment with it, knowingly, put a syntax error into your program, and then see what kind of message you get back, and at what time, which tool gives you the error. Because later on, when you see something like this, you just go, okay, I forgot the % symbol, no big deal. But if you don't do it now, and you make that mistake later on, then you'll be looking at your program and the error message and go like, why would it complain about that? And then it will point you to the wrong place. Okay, I will guarantee you that it will point you to the wrong place. Okay, it doesn't tell you what the error is. It actually tells you something that seems to be irrelevant. Okay, so now we are getting into the good stuff. Okay, because this particular operand is what you need for the homework assignment. It's called a direct addressing mode. In the direct addressing mode, in this particular case, this is our first memory operand. There are plenty, okay, but they're all related in a way. So we'll take a look at this particular instruction. The question is, what is it going to do? Which one is the source operand? The first one, the left one, is the source operand. It's $1, okay? What kind of operand is it? An immediate operand, okay? And what is the value of the operand? Zero itself, exactly. In other words, the source of this particular instruction specifies, 32 zeros as a binary digit, okay? 32 bits and they're all zeros. That's the source. We are moving or copying 32 zeros as bits to some place. We're not copying to a register because the second operand doesn't start with a % symbol. It is not EAX, EBX, or so on. It is 0. Well, if you see a number or an expression without parentheses and without a % or without a $ symbol, it is a direct operand. Okay, it's a direct memory operand. What it is it can be as simple as a 0. It can be a label. It can be a super long expression this long. It doesn't matter. It has to evaluate to a 32-bit bit pattern. And that 32-bit bit pattern will be used as an address. And that address specifies, in this case, the destination. Are we kind of doing okay so far or not? Okay. In other words, in this case, you are basically just telling the instruction where in memory is going to get overwritten by 4 bytes of zeros. Okay, which seems pretty simple. Now location 0, okay, I'm just going to read through the whole thing here. A direct operand is specified by an expression that evaluates to an address, and in this case, 0 is the address, and it will cause a segmentation fault in this case. The 0 operand, the first operand is the source, which is a $0, which means it's an immediate operand. It specifies a value of 0. It is not the value at location 0, it is 0 itself with the $. The destination operand is 0 without the $. It is just an expression. The destination operand is a direct operand that specifies location 0. So in this case, we are not only trying to overwrite location 0, but because location 0 is a byte, and we are trying to copy 4 bytes. So this instruction is actually going to try to overwrite location 0, 1, 2, and 3. Those 4 bytes are actually collectively the destinations of this particular opcode. Now, since location 0 is usually not allocated to a process, the execution of this instruction will cause a GPF, general protection fault, in Windows terms, and segmentation fault in Linux terms. A segmentation fault, or seg fault, essentially means a process attempts to access memory locations that it has no permission to access. That's pretty much it. In general, we don't use a numerical constant for direct operands. Instead, we use labels that are defined as the first location of some allocated memory. Let us take a look at listing 5.3, which is this code here. So in this case, we have a dot data section, and in it, I define label 1 to be the address of .int 0x5. In other words, this instruction, or this, I shouldn't say instruction, this directive here is going to allocate 4 bytes because it's a .int, and .int means we want to allocate bytes, and each item is going to take up 4 bytes. There's only one item here. It has a value of 5. So that means we're allocating 4 bytes in order to store the value 5 as a 32-bit integer. It would take up 4 bytes. Last time we talked about little endian, okay, the convention of storing the least significant byte first. So in this case, it will take up 4 bytes. The first byte has a value of 0.5 in hexadecimal, and then the other 3 bytes are all zeros because they're all more significant than the byte that is actually just needed in this case. And then we switch to .text because the instructions should go to the .text section. So when we execute, or when we see this instruction here, move $23 to label 1. The first operand, once again, is an immediate operand. It specifies the bit pattern, the 32-bit bit pattern that represents the value 23 in decimal. Okay, it's just a bit pattern, 32-bit. That's the source. We are copying that particular bit pattern to label 1. Now, what does it mean when we copy to label 1? We are not changing the definition of the label itself. Okay, you cannot do that. Once a label has a value, you cannot change the definition of the label. In this case, we are looking at label 1 as an expression, nothing more than just a regular expression. Label 1, which is an address, which is defined to be an address, is nothing more than a 32-bit bit pattern again. But in this case, it is used, or it is interpreted as an address. And in this particular case, we are trying to overwrite the 4 locations starting at label 1 with the 32-bit bit pattern that represents 23 as its value. Are we doing okay so far with this? No?